Hello and welcome to a new video on IGCSE Classified Paper 2 Physics. In this video, we shall be dealing with the topic of resistance combinations. We'll start with the basic questions. The idea is as follows. You should understand that if we connect resistors in series, if, for example, the first resistor is 5 ohms, the second resistor is 3 ohms, then the total resistance will simply be the sum of these two, which is 8 ohms. If we connect them in parallel, so this would be 3 and this would be 5, the total resistance will be as follows. 1 over R total is equal to 1 over 3 plus 1 over 5. This is equal to 8 over 15. So R total equals 15 over 8. And 15 over 8 in decimal is 1.875. So we notice that it has to be smaller than the smallest value here. So the total resistance is going to be definitely less than 3. How much precisely? We have to use the equation to calculate it, but it's sometimes smarter to just figure out that the value of the total resistance is going to be less than 3, less than the smallest resistor in the combination. Without having to calculate it, we can just figure out the correct choice based on that assumption. So let's seek some examples here. The diagram shows a 3 ohm resistor and a 6 ohm resistor connected in parallel. What is the total resistance of this arrangement? So you should understand that the total resistance has to be less than 3 ohms. Regardless of what the actual value is, you don't have to calculate it. You should just understand that it will definitely be less than 3 ohms. Why is that? Let's analyze this physically. So if I only have a 3 ohm resistor here, the current is all passing through this resistor. If I add another resistor here of whatever value, let's say 10 or whatever, this is similar to adding a new path for the current to flow. So you can compare this to cars on a road. The cars want to move from point A to point B. Initially, they all had to go through this road, but then we constructed a new road for some of the cars to take. So is the situation better or worse for the cars? Of course, it's better because instead of one road, now they have two. So regardless of the numbers, regardless of the values, this combination is definitely better for the cars than just having a 3 ohm resistor. In electrical terms, this means that the current will flow faster if you have this parallel combination, or that the total resistance is less. So the total resistance here must be less than 3. This is an important concept to understand. So the correct choice here would be choice A. This is a similar question. We have two 5 ohm resistors. What is the total resistance of the combination? Again, it has to be less than one of them. And if they have different values, it has to be less than the smallest one of them. So A here is the correct choice as well. Two 3 ohm resistors are connected in parallel. Which statement is correct? Of course, it is less than 3 ohms because I have 3 up and 3 down. So again, the combined resistance is less than 3 ohms. The diagram shows two resistors connected in a circuit. What could be the combined resistance of this arrangement? It has to be a value less than 6 because we said it has to be less than the smallest value. So the only correct value here is 4. So A is the correct choice as well. This is a similar question again. We have 20 and 30, so it has to be a value less than, excuse me, it has to be a value less than 20, so 12 is the correct answer. So A is the correct choice here as well. We'll proceed now to more analytical questions. We want to get the total arrangement of this combination, the total resistance, excuse me, of this arrangement or of this combination. So we said that the effective resistance of this part has to be less than 6. So this is as if we have a 4 ohm resistor connected to a resistor that is definitely less than 6. This sign means less than. It's an inequality sign. So what is the effective resistance of the blue combination? Let's call it R. So if I want to describe R, if this is going to be just one resistor, what can you tell me about R? Remember that if we have two resistors in series, let's say 3 and 5, the total resistance is going to be 8. It's the summation of the two resistors in series. So similarly, in this case, the total resistance is the summation of 4 plus something that is less than 6. So what can you tell me about R total? Well, you should be able to realize that R total has to be greater than 4, because we have 4 and we're adding something to it. So it's definitely greater than 4, and it's definitely less than 10. Why is it less than 10? Because this number is less than 6, so it's 5 or 4 or 3 or whatever. So 4 plus something that is less than 6 will definitely give me a number less than 10. So the only number in the choices that lies between 4 and 10 is 7.4. Right? So let's summarize this quickly again. By looking at the choices, we definitely know that the arrangement is 4 plus something else. So we exclude choice A. And we know that this combination is less than 6, so the total has to be less than 10. So we exclude C and D, and B is the correct answer. If this is too confusing for you, you can always use the equation to calculate the actual resistance. So this part here, for this part, 1 over R total is 1 over 6 plus 1 over 8. And this would give us 7 over 24. So R total is 24 over 7. I just flipped the fraction. 24 over 7 in decimal gives us 3.43. So if we rewrite the circuit, redraw the circuit, this will be 4 and this would be 3.43 or 3.4. Then you add them together, so the answer is 7.4. So this is another correct way of solving it, but it takes more time because you actually do the math. However, just doing it analytically could be a lot quicker. So either way, the correct choice is B in this question. Identical resistors are connected together to form arrangements X, Y, Z. What is the correct order of the resistances of the arrangements from largest to smallest? So remember, let's just, for ease, let's just say that all of these resistors are 5 ohms. So Z, arrangement Z, gives us a total resistance of 15 ohms. Arrangement Y gives us a total resistance of 10 ohms. Arrangement X gives us a total resistance of something that is less than 5. And also for your information, if they are equal, the total resistance will actually be the half the value of each. So it will actually be 2.5 here. This is something that would also save you some calculation time. If you have two resistors of the same value connected in parallel, then the total resistance is half of each value. So anyway, here it's obvious that Z has the largest. We are arranging here from largest to smallest. So I will go from Z to Y to X, and D would be the correct choice. In which circuit will the ammeter reading be the greatest? So this is a bit more advanced because you need to figure out how to maximize the ammeter reading. So the ammeter measures current. And we know that V is equal to I multiplied by R. So to maximize I need to minimize R because they lie on the same side of the equation, so they're inversely proportional. So in order to get the highest ammeter reading, I want to get the smallest resistance. So which of these arrangements gives me the smallest resistance? Well, first of all, analytically as well, you should figure out that A and C are exactly the same. The ammeter is going to read the exact same amount. So how does that help me? If both of them are exactly the same, they're both definitely wrong, because why would I choose A and not C? Or why would I choose C and not A? That doesn't make sense. So we can just remove these two from consideration. Also note that they're connected in series and they actually have very high resistance. But I mean, like even if you don't think about that, A and C are exactly the same. So there's no point in choosing one of them. So is it B or is it D? Which one of them gives me the highest ammeter reading? Well, this has to do with current branches. So remember that we said that the current goes into this point like this. This is the total current, which is the green current. And then it splits off into the blue current and the red current. So the green is obviously higher than either the blue or the red. In fact, the green is equal to the sum of the blue current and the red current. So which one should I choose? Where will the ammeter reading be greatest? Of course, in B, because in B, the ammeter is going to read the green current, whereas in D, the ammeter is only going to read the value of the blue current, right here. So B is the correct choice. Which change to the circuit would increase the current in the lamp? Again, to increase the current, E equals IR. To increase the current, you need to decrease the resistance. So how would you decrease the resistance? By adding a resistor in parallel, because we said that if we add any resistor in parallel, the total resistance decreases. B is wrong because if you add in series, the resistance increases. C, if I decrease V, then this is wrong because I don't want to decrease the EMF. In order to increase I need to increase V. So it should have been increasing, not decreasing. D has absolutely no use because if you just move the lamp, this does nothing to the current. The current will stay exactly the same. So again, this is wrong as well. So the correct choice here would be choice A. Adding a resistor in parallel will decrease R and therefore increase I. The final part of this video concerns questions that require calculations. So we'll actually have to calculate the total resistance in these questions. So I have a 3 ohm resistor and a 6 ohm resistor connected in parallel. What is their combined resistance? So why can I not do this analytically like I did before? Well, the idea is, or the issue is that analytically you can rule out C and D. So C and D are definitely wrong. Why are they wrong? Because we said it has to be smaller than 3. But is it 0.5 or is it 2? To be absolutely certain, it would be better to just use the equation and to calculate. So 1 over R total is equal 1 over 3 plus 1 over 6. And this is equal to 3 over 6 or half. So our total is the inverse of half, which is 2 over 1, which is just 2. So the correct choice here is choice B, 2 ohms. A 12 ohm resistor and a 6 ohm resistor are connected in parallel. Another 6 ohm resistor is connected in series. What is the combined resistance of all three resistors? Again, here, just doing it analytically won't work because you still have more than one option that could work. So we just calculate the effective resistance of the parallel part first. 1 over R total equals 1 over 6 plus 1 over 12. And this is equal to 3 over 12. So R total equals 12 over 3. And this is equal to 4. So I can redraw the circuit and just put a 4 ohm resistor here besides the 6 ohm resistor. So the total would be 10 ohms. So the effective resistance here would be 10 ohms. Which combination of resistors in parallel has an effective resistance of 0.5? Well, this doesn't really need calculation. If you remember what we said earlier in this video, that if you have two resistances that have equal values, the combined resistance is going to be half of that value. So without calculating, we can confirm that A is the correct choice, but let's do the calculation anyway, just to make sure that you are aware of what's going on. So 1 over R is going to be 1 over 1 plus 1 over 1. So 1 over R is just going to be 1 plus 1, which is 2. So R is going to be 1 over 2. So for A, the effective resistance is 0.5. And if you do the other ones, you'll get here that the total resistance is 1 because it's half of 2, and that the total resistance here is 2, which is half of 4. For C, you still have to do the fractions and the flipping and so on in order to calculate it, but we know it's going to be something less than 1, but maybe something greater than half, a little bit greater than half. So the correct choice here is choice A. And this brings us to the end of our video. I hope this was useful. Thank you for watching.